If you don't start, you can never be the greatest. So get started.
Boom. Okay, today what are we doing today? Today we are doing sketching of cubic functions. What are cubic functions? Anything that has x to the power of 3 or whatever function it is in sums to the power of 3, that's the highest power. That's a cubic function. So today let's look at the general formula for cubic functions, right? So that you have this embedded at the back of your memory. You should have an idea of it. So g of x is equal to a x cubed plus b x squared plus c x plus d. This is the general formula. That's the general formula for your cubic functions. Okay, what is this a? No, sorry, what is that d? D is your y-intercept. What do I mean by that? If I want to find, let's say I make all the x value 0, right? So that I make that the x is at 0. Our g of x is equal to d, which is the y-intercept. It means it passes the y vertical line at that specific point, right? Okay, so let me show you a little bit of something. So let's look at if a, right, that a value is less than 0, right? Okay, let's see what it looks like. What does it look like? If a is less than 0, it means that the graph will start with the local minimum. You should remember this from the other video. Right? It starts with the local minimum when a is less than 0. So less than 0, local minimum. Okay, so that makes sense, doesn't it? Okay, so now let's look at if they say draw the graph of g prime of x, right? So they want you to draw the graph of g prime of x, right? So what do? You look at it like this. G prime of x will pass through the x intercepts will be the same points of the turning points, the x turning points. So what does my graph look like? It looks like this. It becomes a hyperbola. Right? So let me write this. This is g of x. But this is g prime of x, right? So if that's g prime of x, right? What does my g double prime of x look like? My g double prime of x will obviously pass through again the x corner of the turning point. What is my turning point here? My turning point is, let's say it's somewhere there. So my turning point would be there. Right? My turning point is right there because it's the turning point of the g prime, not the turning point of g of x, because the turning point of g of x would determine my intercepts for my g prime graph. So g double prime will now be a straight line, right? Because it was a hyperbola and then now it becomes a straight line. So my graph would look something like this. Right? So this will be g double prime of x. So this is what my g double prime of x graph would look like, right? But if a is, let's say, greater than 0, the only difference is that, let me just draw a little sketch over here. The only difference is that the graph will now, instead of starting with the local minimum point, it will start with the local maximum. So it will look something like that, right? So that's when a is greater than 0. And again, the same thing occurs for your g prime of x and g double prime of x. So you have to use, to find g prime of x, you have to use those turning points there. And the graph will pass through that. And now since it started with a local maximum, the turning point will be for the g prime would be a local minimum. So this will be what your graph, some shape of what your graph might look like. Right? So that would be, this is g of x, this g of prime of x. So what does it mean? What does my g double prime of x look like? Again, you should know this now. So it's now over here. It's the turning point of g prime of x, which is right there, let's assume it's at 0. So this will be my line that passes through 0.
If you are stuck with a problem, ask a friend, ask the teacher. First ask your friend. If he or she doesn't know, then you can go and ask your teacher or someone of higher power. But you should try ask people that you know, because they might be able to explain it to you better than how the teacher can explain it to you.
And that's G, let me write G double prime of X, right? So that's basically it on looking at the shapes of these graphs of cubic functions. So now you should have this embedded in the back of your mind, this type of shaping and all that. You should know this. This should come to you naturally. So let's look at an example for sketching of cubic functions, right? The example, let's say, let me erase this. Okay, so now my example one says, sketch the graph of g of x, which is equal to x cubed plus 2x squared minus 3x minus 4, showing all points on the graph. Okay, so what do we do? Let's look at it step by step. So step one, what is step one? Again, you can mix these steps, because you can't do the second step before you do the first one. But as long as you do those steps, right? So step one, my step one, I like to do it in this order. Step one, I don't even need to draw a visual of this. Why? Because I can find all these things without visually looking at it. But if it helps you, you can draw your visual on the side, right? So step one, my step one I say is determine the intercepts. Determine So what do I mean intercepts? The x and y intercepts. So this will be x and y intercepts. Right? So what do I want to start with? Let me start with an easy one. Let me determine the y intercept, right? So if I determine the y intercept, how do I determine the y intercept? I think I already spoke about this. I can determine the y-intercept by making x equal to 0. So let's do that. So y-intercept, I'll let x equal to 0. Why do I let x equal to 0? Because I know it passes through that vertical line in the middle when x is equal to 0. That's when it passes that vertical line. That vertical y-intercept, right? So that's how you end up with a y-intercept. That's how you end up with x is equal to 0, letting x equal to 0. So if I let x equal to 0, let me look at my graph. G of x now is equal to 0 cubed plus 2 times 0 squared minus 3 times 0 minus 4. What does this mean? This means that this and this and this are equal to 0. So my y-intercept is now negative 4. So what is my point? Don't just leave it there, make it a point. So my point is negative 4. My point is 0 and negative 4. So it rises up from the bottom to negative 4. But it's not on the side, because again, y-intercept only occurs when x is equal to 0. So that's my y-intercept. And if you look at this carefully, you don't really have to do that calculation. You can just see by looking that this in your equation now is D. So you know that your y-intercept will be negative 4. You don't even have to do that calculation. So now let's look at the x-intercept. A little bit more complex than the y-intercept. Okay, so now looking at the y-intercept, right? I mean the x-intercept. What do we do? What did we do last time? We let x equal to 0. But now we're looking for the x-intercept. It means that the x will be 0, because this point will be lying on the horizontal line. The horizontal x line. That's where we'll find the x-intercept. So what do? We say let y equal to 0. Okay, we let y equal to 0. Okay, let's see what happens if we let y equal to 0. So now in our equation, now we have 0 is equal to x cubed plus 2x squared minus 3x minus 4. Okay, this looks a lot more complex than the last time when we made x equal to 0, because because y is only one coordinate. It's only one point in this whole graph, in the whole equation. So now what does this mean? This means that we're going to have to use the factor or synthetic theorems, right? So I'll use the synthetic. First I'll factor out and see which factor do I know, right? How do I get that factor? By try and error, right? So I'm gonna try and see what value I can put it, which I can put into this, which will reside into 0, right? So if I chill. If I try x is equal to -1, this will result in, this will give me 0. If I try x is equal to -1, I will get 0. This side here will be equal to 0, right? So if that side is equal to 0, it means that that is a factor by try and error. So I'll write down x is equal to -1. That's one of my factors. So I know I should have 3 values. So basically what that means is I should have 3 intercepts, 3 x intercepts. So now I have one of them. So let me use synthetic division. So I have 1, 2, -3, -4. So I'm hoping that you remember how to do the synthetic division. If you don't remember, go get comfortable with it. Go revise on this. Okay? So knowing the rules of synthetic division, I have to put the -1 here. Right? Right? And why do I have 1, 2, -3, -4? Because those are the coefficient of the equation, right? If I didn't have x over here, it was just x cubed plus 2x squared minus 4, I would still have to put 0 over there. Do not miss that. It rises in power of x to the power of 0 for the first one, x to the power of 1 for that region. So I can't miss one. I can't go from x cubed here to x. I have to have a 0 there if I do not have an x squared, right? So now what do? I put my factor on the side over here, and I put all those numbers along that line, right? So now what do? I have to put a 0 here before I start, right? And then I add the top line and the bottom line. So what's 1 plus 0? It's 1. -1 times 1, -1, right? -2 minus 1. Why? Because it's 2 plus -1. So 2 minus 1 gives me 1. 1 times -1, it's -1. -1 plus -3 plus -1 gives me -4, because it becomes -3 minus 1 gives me -4. -4 multiplied by -1. What does that give me? Gives me +4. So if I say -4 plus 4 is 0. It's 0. Yes, of course it's 0. It makes sense. It's supposed to be 0. If it's not 0, you did something wrong. Okay, so now what do I do when I get to this step? Once I get here, what I do is now I lower the equation by 1 power. So now the first number here in the bottom line will be 1. That will be the coefficient of the first power. So the coefficient of x squared will be 1. And the coefficient of x that follows after that is 1. So whatever sign that is there, you take it. So the last one does not have does not have an x. It will be -4, right? So you have to take the sign with you. What is that equal to? It is equal to 0. Okay, so now I have this equation, right? But now I don't know how to solve this easily. So what do? I bring my quadratic equation. And you should remember this. I'm not writing it down anymore. You should remember that a quadratic equation at the back of your mind. So my quadratic equation will give me x is equal to 1.56 and x is equal to -2.56. But these are not my only 2 intercepts. I should have 3 intercepts, 3 x intercepts. Why? Because it's a cubic function. It crosses the x horizontal line 3 times, right? It doesn't always have to, but in this case it does. So that's why I should have 3 coordinates. So my 3 coordinates would be 1.56 and 0. The second one is -2.56 and 0. And my last one is the one that I found above by try and error, which would be -1 and 0. Right? negative 1 and 0. So those are my 3 x-intercepts. I have 3 x-intercepts and those are the ones. So what do I've done step 1. Step 1 says find intercepts. So I found all my intercepts. So now since I have all my intercepts, I have to go to step 2. What's step 2? Step 2 is to find. Step 2 is determine the stationary points. For me to draw a cubic function, I need to know the stationary points too. So all the time. Huh? What is that? Points. So how do I determine the stationary point? I'm pretty sure you remember how to determine a turning point or a stationary point. I have to find g prime of x and equate it to 0. So let me do it. Let me do it right here. So this will be step 2. Turning points. Right? So determine turning points, however you want to write it longhand. Alright? Turning points or stationary points. Right? So what's the first step that I need to do in determining turning points? I first need to find out what g prime is. First derivative. So g prime of x is equal to 3x squared. Again, get comfortable with your derivatives. You need to use them all the time. So this will become 4x minus 3, right? Okay, so that's my derivative, right? That's my first derivative. Right, now to find the turning point, I know that I have to equate this to 0. So this becomes 0 is equal to 3x squared plus 4x minus 3, right? So I can just plug this into my calculator and see what values I get. X is equal to, these are the two values that I got. X is equal to 0.54 or x is equal to negative 1.87, right? These are my two x coordinates of my turning points. So now what do I need? I need the y coordinates of those because I need a point. Right? So I'll insert this not into g prime of x, but into the original g of x and then see what values that I get. So you can try that right now as I write this. Right? So for both of them, the values that I got for the first one, g of 0.54, I got negative 4.88. Negative 4.88. And for the second one, g of negative 1.87, when I substituted it, what I got was 2.06. So what does this mean? This means that I have a y and an x coordinates for my turning points. So let me write them down on this side over here. So turning points, right? So the first one is 0.54 and negative 4.88, right? The second one is negative 1.87 and 2.06, right? So those are my two turning points, right? So step 2 is complete because I have my turning points now. So what is step 3? Step 3, no, it's not sketching it yet. Step 3 is very important. It helps you to visualize what you're going to be drawing. So step 3 is find out what the shape is. How do I find out what the shape is? I find out what the shape is by using A, looking at A. Right there, the coefficient of x cubed. What does A determine? It determines whether we start with a local minimum or local maximum. So in this case, A is positive. If A is positive, it means that we start with a local maximum, right? It only makes sense, right? A is greater than 0, so we start with the local maximum. So the shape of the graph should look something like that, right? Because we start with the local maximum, right? So that's step 3. That's it. Now step 4, of course, the final step is to sketch. Final step is to sketch. Okay, so let's sketch the graph. Okay, my graph might not look perfectly amazing, but you should try to make it as nice looking as you can, right? It's still freehand, and my freehand is pretty questionable, right? So there we go, right? Those are pretty straight lines, and we are starting a good run. So what's the first points that we need to put on our graph? I would suggest we look at the turning points first, right? So I'll put my turning points. My turning point is 0.54 and negative 4.8. So it'll be somewhere here, right? 0.54, that's the x, negative 4.8. 0.88, right? That's my first turning point, right? Let me label it. You should label all of these points, because that's why it says show all points on the graph, right? And then we have negative 4.88. That's my first turning point. My second turning point, it says negative 1.87. So negative 1.87 somewhere here, and it goes up 2.06. So goes up 2.06. What's important is the shape. It's not really about how well you sketch.
Go and study, not just because of what your parents say, because your parents are forcing you to study. Because I promise you, you end up with a degree that you don't like, and a lot of wasted time that you could have spent doing something more useful or studying something that you liked.
Grades you had freehand. It's a matter of, does it look right? Right? So now I have my turning points. So I'm complete, check, 2 turning points complete. So what do I move on next to? I move on to my intercepts, right? So I'll prefer to start with my x-intercepts, right? So let me put my x-intercepts. I have 3 of them, right? You still remember what they are. They are right here. 1.56 and 0. 1.556 and 0. Negative 2.56 and 0. And negative 1 and 0. So negative 1 and 0. Where is that? Negative 1 and 0. Let's say it's somewhere here. Right? Negative 1 and 0. And then we have negative 5, 6 and 0. Where is that? Is that before this turning point? No, it has to be after, because this is negative 1.87. So this is what I was talking about shape. Because someone might come and draw negative 5.6 right next to the negative 1. That would be wrong. Your shape will look funny. So this has to be after the turning point. So it'll be here. That's my negative 56.0, right? And what's my last turning point? It's positive 1.56 and 0. So positive 156.0 with 0 has to be after my turning point. It can't be before, because 1.56 is not less than 0.58. So it has to be greater. So it has to be somewhere here. And if you can look at this, you can already see the shape of the graph forming, right? Because we say, what do we say the shape is? It starts with the local maximum, right? That's what the shape is, right? That's what it determines what it looks like, right? So let's draw a graph. Let's draw in the points. And we go there, and then there. And as you can see, my graph looks pretty nice, if you ask me. It's a pretty perfect graph, actually. So we have all our points. What do we not have on our graph that we haven't labeled? The x, the y-intercepts. We haven't even spoken about it. So I usually like to do that one last, because I'll just point wherever it intercepts the y line. As long as it's below the last turning point, you'll be fine. So that will be, my y-intercept is negative 4, 0 and negative 4, which makes sense because this is negative 4.88. So this will be 0 and negative 4. This one now was negative 1 and 0. This one's 1.56 and 0. And this was negative 5.6 and 0, right? You have to label all of your points, right? So that's basically it for this question, but usually what I didn't add to this was a point of inflection. You might have to add a point of inflection in most of your graphs that you do. So how do I find the point of inflection? I go through the process of finding a point of inflection. I find the second derivative of that. I equate it to 0 and I solve for x. Once I get the x, I substitute into the original. Now I have a point of inflection. I have a coordinate. Once I've drawn my graph, right, then I'll come on my graph and then I'll label the point of inflection. Let's say it's somewhere there. Let's just say, for example, that's where my point is, right? It's just below the x coordinate is just below negative 1. And the y coordinate is just below the negative 4, right? So that will be my point of inflection. And I have to label it. I have to say whatever the coordinate is for that point. And of course, I'll get marks for the shape of the graph. Fine, this can be a lot of marks for you. A lot of free marks, easy marks, systematic marks. You can practice this, right? And then you get those marks for free. So this is basically it. So you probably get like 2 marks for your shape, and then another maybe 3 marks over here, 3 marks for your intercepts, and then 2 marks for your turning points. And you have 2, 4, 5, 6, 7. Yeah, you can have 7 marks for this question, depending on how stingy the teachers are. Right? So that's basically it for sketching of cubic functions. So go watch the next video. Okay? Boom!